In this video, we will look at circular measure and an exam style question. You will find this on page 213 in the Namibian AS-Level Mathematics textbook Y equals mx plus c to success. Let's look at this example. And it's actually quite challenging to find that shaded area. So I'm going to try my best to explain it to you. Okay, the diagram shows a rectangle ABCD, that's fine, in which AB is 5, but just don't forget that that is also 5. We will even draw in extra lines also. BC is 3, so that will also be 3. Point P lies on DC, point P lies on DC, and AP is an arc of a circle at P. So this is an arc. Now, I'm going to show it to you there. If I draw a line in there, there's the arc at A and at P. This is then the radius 5. Then this will also be the radius 5. I'll come to that. Okay. And if I draw a line there 3 and I draw a line there 90 degrees, that will also be 3. So there must be a few extra lines included to come to the solution. Okay. So point Q lies on DC. Where is Q? Lies on DC, and AQ is an arc with center D. So again, that's an arc. So if this radius is 3, then this only up to there will be 3. Up to there will be 5. Okay. So with center D. Now, show that angle ABP is 0,6435, correct to 4 decimal places. Now, if they don't put degrees, it means it's radians. So, first thing, stop, put your calculator on radians. Okay, now we can start. Now, if I'm going to find, and now this is the extra lines. So I showed you here, and I'm going to just bring a color in that you can see that. If this is 5, now remember that is going to be a sector. Okay, and there is the arc. Okay, so do you see there? Now, if I want to find angle ABP, okay, ABP, this angle, okay. Now, if this is 5, then this is 5. If this is 3, then this is 3. So if I want to find, there is my 90 degrees, I can work with opposite. So this will be my opposite, and this will be over the 90, the hypotenuse. So it will be sin of this angle equals opposite 3 over hypotenuse. Remember, your calculator must be on radians, and press shift sin bracket 3 divide 5, close the bracket, and approximate to 4 decimal places. There's also a printing mistake. I should have write there angle, because that is the ratio. This is the angle. In the second print, I will correct it and just write angle ABP is equal to 0,6435. Okay. Now, the reason why they gave you this, so that if you go further, say you don't reach that answer, but then at least work with the correct answer. Don't use the incorrect answer in B and C if you didn't come to that answer. Use the correct one. Okay, that's finished. Let's go to B. Calculate the areas of the sectors BAP, its area. Don't forget, its area. Okay, let's start with BAP. Okay, now where is that? BAP. Okay, so it's actually this one, and that's why they gave you the angle. Now, what is the formula? It's half, can you remember, in radians? So it's r squared times the angle. So half r squared, 5 squared, times the angle. And again, make it at least to 5 decimal places. Okay, so 1, 2, 3, 4, 5, just for your accuracy later on. Now, find the area of angle of this. So actually this one, I could have made that one in red. And maybe we can now make this one in green. The area of DAQ. Now, where is DAQ? Let's just find it. DAQ. I'm going to try to find it again for you with lines. DAQ. And it's again Let's get my pen correct. This one, and then it would be this one. Okay. Okay. So if I must find, now don't forget that this angle is 90, but in degrees, but in terms of radians, it's pi over 2. So I do exactly the same. There is my angle, I have it. So it's a half the radius square multiply the angle. Okay. And I can keep it in terms of pi if I have it. Okay. But it's not necessary, it's just more accurate. Now, calculate the area of the shaded region. Now, that was quite challenging to see that. So I was trying to help you with the picture. Now, I'm first going to get the area of this unshaded. And then I'm going to get the area of that unshaded B. And then I'm going to end up with that. Okay, and then I take the whole rectangle and I subtract this unshaded and I subtract. There can be a shorter way. There's always a lot of methods. This is the method I followed. Okay, now if I want to find the area of this one, this unshaded there. Now what I did, and I want to show you, let's just see, I can maybe take blue. The trapezium AB, okay, I'm just going to show you that one. ABPD. A, B, P, D. Okay. Now, I'm going to take that one, that one, I work it out, and then I take the whole area and I subtract this sector. Okay, remember? That sector BIP. Okay, let's just find it. Where is it now? BAP. Yes. So if I take, do you see to find A? I take the trapezium. I take the trapezium. That's the whole trapezium. Even show it to you like that. And I subtract that sector, the red. So if I take the blue minus the red, I'm ending up with this. Okay, so the trapezium, so that is to find A. Are you with me? Now, region B, I just showed you that you don't have to work out all. If I want to find region B, now I hope I still have colors left. There is, okay, now this, okay, I think you understand that. So let's just clean this. And I use other colors again to find. So it's again rectangle, let's just make it green, ABCD. So in this case, I'm saying I take the whole rectangle. Okay, it's the whole rectangle. But then I subtract sector DIQ. Now what was D? Okay, where DIQ. If I subtract this one, that sector. Are you with me? Then I'm left with B. Okay, so I wrote it now first just down. So now, if I want to find the area of the shaded, again I'm going to use my picture. And if you have to use colors just in the beginning to help you, just do that. Okay, so if I take the whole rectangle, now to get the shaded, I take the whole rectangle and I subtract this region, A, and I subtract this region, B, which I already wrote. I'm left with the shade. Did you see that? Okay, now I'm first going to write it in. So basically, just to help and not to work out so many, in the place of region A, I put my trapezium and this. So I just substitute that in A. Oh, sorry, my pen was too low. And then in B, I'm just going to say, okay, so B was actually the green. Okay, just to keep a little bit to my colors. Let's try to keep to the colors, okay? So let's just see. So if I wanted to get A, okay, I work in red, it's the trapezium minus the sector, trapezium minus the sector. And B, if it's now green, then it is this one. Okay, that's my rectangle. So I just fill it in. that rectangle. And now look, after you take it out of the, so a negative times a negative is a positive. Do you see what's happening? That is cancelling out. Make it yellow. That is cancelling out. So I'm ending up with sector BIP. There is sector BIP. A sector DIQ. And I subtract the trapezium. Okay, and how do I get a trapezium? It's half height, and remember, where was my trapezium? This was my trapezium. Can I just, I'm going to show it to you here, the trapezium, because that's the only one we didn't work out yet. So if I'm, this is my trapezium, ABPD, A, B, P, D, this is my, so this is my parallel sides, which is 5 there, 5. And if I look at this one, okay, sum of parallel sides, this is going to be 1. Okay, let me see, where did I show that to you? Oh, there I showed it to you. That is going to be 4. Okay, do you see there? Okay, let's just see quickly why it's like that. I want to show you. Okay, so why I did not show it here to you. And maybe I will include it also. Why is this one 4? Because you have a triangle there. And you have that this is 5. And you have this is 3. So with Pythagoras theorem, you can work out that one. So you can say, okay, let's make it x. Let's call that one x. So you can say x is equal to the, because it's Pythagoras theorem, 5 squared minus 3 squared. It's actually the most used one. So it's 25 minus 9. And it's the square root of 16. So that is 4. And that's the reason why. I didn't include it. I think I should include it just here so that you see why that is 1. Okay, so if this is 4, then 5 minus 4, then that will be 1. And then, remember, I have this one, and I substitute. And I have this one, and I substitute. And I work out this one. This is my height. This is my parallel sides. This is 1, and this is 5. So that is, and then I just approximate it to 3 significant figures. It's quite challenging, but I think the more you practice a few of them, the easier it will become. I personally don't think this one is so difficult. Okay, I want you to stop the video and I want you to do try now 57 and A and B. And as soon as you are finished, you can continue the video. Okay, let's start with number A. The diagram shows a semicircle with center O and radius 6. So that is 6. The radius OC is perpendicular to the diameter. There is 90. AB. The point D lies on AB, okay, and DC, this is an arc of a circle with center B. So there is your sector. Okay. Calculate the length of arc DC. So the first thing I want to know this. But what do I need? I need an angle and I need this line. Okay, so this is what I need. And I'm going to make use of this triangle here. Now what I'm going to do, if this is 6, this is also 6 because this is so this is the radius, this is also the radius. So I can find this angle, okay, because now it's going to be an isosceles triangle. So if this is 90 degrees, this is going to be 45, but in terms of radians, it's going to be pi over 4. Okay, so let's start writing. Okay, let me first finish talking. So this is going to be pi over 4. I can work out this line because if this one is the radius, then this is the same as this one. Now, how can I work out this hypotenuse? I have a 90-degree triangle. I have two sides, so I can work it out with Pythagoras theorem. And that's what I'm going to start. Okay, but let's start with the angle. Let's say angle CBD, okay, CBD is going to be 45 because, as I said, it's going to be 180, okay, let's just work first within degrees, maybe you understand it better. Divide 2, and that's 45. But in terms of rad, it's going to be pi over 4, because 90 is pi over 2, so 45 is pi over 4. Okay, that is my angle. Then I'm going to work out the hypotenuse BC. So I'm going to say, let's just, it was green. So BC squared is equal to 6 squared plus 6 squared. So BC is equal to 36 plus 36, which is 72. Okay, that's BC. Not plus minus because it's a practical, it's distance. Otherwise, it would have been plus minus. Now I can start and say, okay, length of arch is the radius and the angle. And what is the radius? Remember, I said if this was square root 72, so this will also be square root 72. So that is going to be square root 72, and the angle is going to be pi over 4. And if I work it out, let's just see, calculate the length of the arc DC. I can work it out on my calculator. I can press shift, pi, divide 4. I always like to first get rid of the pi, and then multiply square root 72 equals, and then three significant figures, 6.66, and that will be centimeters. Okay, and now I go to number B. Find the value of the area of region P. Okay, now just see where is P. I'm just going to clean, otherwise you cannot see so good again. Okay, there is P, do you see? And there is Q. Okay, so find it as a ratio on top of it, giving your answer correct to three significant figures. Okay, so let's start first by seeing how will I get Q. I think I'm going to make this. I want to use the, okay, let's see Q. Now, can you see I can take the area of this sector and I subtract that triangle. Okay, so let's do that. So region Q, it's area, remember we have only the arc length of sector BCD minus area of triangle BOC. And move a little bit. See that, see. Okay, so the area of the sector, we have everything. So the formula, okay, I'm just going to start with the formulas. That's the area of a sector. That's the formula for the area of a triangle with 90 degrees. So it's going to be a half. Let's keep to the radius. It's going to be 72 squared. And let's keep to the angle. It's pi over 4. Minus, okay, this is the base. It's 6. What is the height? It's also 6. Okay. And now I can work out this. Now, this is very nice. As soon as you square a square root, then it's going to become 72. So it's 72 divide, because this is going to be 4 times 2 is 8. So it's keep it in terms of pi. It's more accurate. 9 pi. And that is 36.5 is 18. Okay, let's first keep it like that. And then I'm going to find, and now if I must find Q, okay, here is Q. Can I just show you what color will we make? Green. Okay, so region, P, did it incorrect. Region P is equal to area of sector OAC. Okay, sector, let's just show you, sector O, A, C. So it's this, it's actually a quarter of a circle. Okay, a quarter of a circle minus region Q. Okay, remember, so if I just a quarter of a circle minus Q, I'm getting P. Okay, so area of, it's actually a quarter circle, as I said to you. You can do it like that. I want to show you both ways. Okay, I'm going to show you the other one. So I just forgot minus region Q. Okay. But let's first do the sector formula. Then it's going to be a half. It's going to be the radius. Remember, if this is 6, this is also 6 squared. And what is 90 degrees? It's pi over 2. Okay. Minus, okay. I just want to show you quickly this one. You could have also said it's a quarter of a circle. Now, what is the area of a circle? So the area of a circle is pi r squared. So a quarter is just divide 4. So if I'm going to say it's going to be pi, what is the radius? 6 squared divide 4. Now, let's just see what do I get if I do that. It's going to be 36 divide 4 equals, and that is going to be 9 pi. Okay, let's see if we get the same. I was just working a quarter circle now. Let's get this one. So it's exactly, it's 36 divide 2 times 2, 4. It's 9. So it doesn't matter. You can either say a quarter of a circle or you can work with a sector. But at the end, your answer will be as long as you come to 9 pi. And what was that region? And this is why I was keeping in terms of pi if I can. Okay, now let's bring it up. So this is going to be 9 pi minus 9 pi plus 18. Cancel, cancel. And that is just going to be 18. Okay, and now I go for my finals. I say area of region P, therefore area of region P over area of region Q is that 18 over 9 pi minus 18. Okay, please don't cancel that. It's 2 terms. So just press it on your calculator. Press 18, divide bracket. 9 multiply shift pi minus 18, close the bracket, equals. And my final answer is just 1,75. And that is my ratio. And that's how I do it.